So in the past, what we have done, we talked about priors and about hyperparameters, and sometimes these hyperparameters are fixed, elicited, and we did not really focus how to elicit those and how to specify the priors. The priors are popularly called swords and Achilles' heels of Bayesian inference. Swords because they're very powerful, they incorporate nicely any prior information, any expert opinion, but at the same time, the misspecification of prior or subjectivity, which is not founded on the reality, may impair inference and sort of affect the inference. That was the basic criticism of Bayesian statistics, that the priors are subjective and the whole inference is not really objective. However, I will quote the Gastweit and Dickey, who said that expert personal opinion is of great potential value and can be used more efficiently, communicated more accurately, and judged more critically if it is expressed as probability distribution as prior. So how to elicit priors? There is science of this. People elicit priors in different ways and set the priors in different ways, and this unit is going to talk about ways how to elicit priors. If you are sure about the family of distributions that prior belongs to, but you are not sure about the numerical characteristics, you may want to specify some values such as mean, variance, moments, quantiles, mode, and these will specify the prior. For example, let's say that you decided to put exponential prior on the parameter data. The exponential prior would have the hyperparameter lambda, but you know that data is elicited to be about 2. That can be used to say that expectation of the data is 1 over lambda, theoretically, and then 1 over lambda is 2, and you elicit that lambda is 1/2. Or, for example, let's say that you have the same exponential family, but expert tells you that median is equal to 4. What does it really mean is that 50% of time you see the lambda less than 4, and 50% of time you see lambda bigger than 4, and that may be expert's opinion. Then simply that would be sufficient to elicit lambda, because if you evaluate CDF at 50th percentile, you get the half, or in this case, f of 4 is equal to 1/2. F of 4 is, for exponential distribution, is 1 minus e to the minus 4 lambda, and this is 1/2, and you end up solving with respect to lambda. So lambda is, in this case, about 0.1733. So that would specify the prior exactly. So there are many cases when you specify some moments, variances, quantiles, mode, and that will result in prior. There is another example, how to elicit beta prior if you know that expectation of this beta should be 1/2 and the variance is 1/8. You start with beta, which has hyperparameters alpha and beta, and they need to be specified to be connected with this information here. So you know that expectation for the beta is alpha over alpha plus beta, and that is 1/2. And this leads to the fact that alpha is equal to beta after you take this into consideration. Then you know that variance of beta distribution is equal to this expression, theoretically. And 1/8 is equal to the variance. You incorporate alpha equals beta in here and get equation only depending on alpha, and that equation is equal to 1/8. And you solve with respect to alpha, resulting in alpha being 1/2. So in this case, since alpha is equal to beta, the distribution, beta distribution that satisfies expectation is 1/2 and variance 1/8 is beta 1/2. In general, if somebody gives you expectation of data to be mu and variance to be sigma square, then you can simply elicit hyperparameters of beta, alpha, and beta using this information.